So my name is Michelle Workman. I am the manager of the Natural Resource Department for East Bay Municipal Utility District. That's a big title. We're going to talk about what that means. So today, what we really want to talk about, I'm going to start by just talking about, like, how do you become a fish biologist? Like, what's the career path? Is it cool? Is it not? Like, what I think about it. And then we're going to discover a little bit more about the Mokelumne River Watershed that hopefully I can give you some new little tidbits of information. It sounds like you guys have all been up to the hatchery, which is very cool. We're going to learn why the hatchery is there, what it does, what we're trying to gain out of that, how the salmon use it. And then we're going to talk about how EBMUD helps with the ecology of the river and monitoring these fish in the river. And we do that through a couple different ways. We look at fisheries monitoring, so actually handling fish, habitat restoration, so making the habitat the best it can be for the fish, and then trying to manage flow and temperature so it's optimized. So salmon, which are cold water species, salmon and steelhead, have the best environment possible. So my career, I do a couple pictures of me young and working in the field, catching fish and doing work. And then this is what happens when you get older. You get suited up and you get out on the river much less, but still a great, great career. So for my career path to be a fish biologist, I went to college. I have a four-year degree, a bachelor's of science degree in conservation biology, and then I have a master's degree as well, which is an additional 2 years of college. So that 6 years of college for me turned into 10 because I decided to have a couple kids kind of in the middle of it, but still doable. And then the typical pathway really to become a fish biologist is like a lot of seasonal jobs, like really fun, like short-term jobs that focus on one species or one habitat. And there's lots of cool jobs like in the Central Valley. Like I monitored for spadefoot toads. I monitored for tiger salamanders and giant garter snakes. I also monitored fish populations up in the mountains, so some different species than we see down here. So it took lots of different jobs to kind of get enough experience under my belt that someone would want to hire me for a permanent job. They think, hey, she knows a lot because she's been doing all these different things. And then I got hired by EBMUD, first as a technician, so that's me going out, schlepping nets, fixing equipment, and doing all the grunt work, and then slowly promoted to a fish biologist, then to a supervising biologist. My most recent position was manager of the Fisheries and Wildlife Division, which I held for about 6 years. And then now I'm the manager of a whole department. So I not only manage the fisheries and wildlife component, but I also manage our watershed and recreation programs. So like Comanche Reservoir has boating and fishing. We do grazing on the landscape to keep vegetation down, to protect from wildfire. I'm in charge of all those programs too. The one thing I like to tell people when I talk about the job of being a fish biologist, ultimately lots of people will say, how much do you make? And my answer to that is always, being a fish biologist is not about how much you make. It's just about doing what you love to do. So you really have to have a love of the outdoors and love being outside, a love of science, an inquisitive and analytical mind. Like you want to answer some questions, like find some data, pull data together and figure out if you can make things better. And then that typical education I talked about, bachelor's degree, master's degree, you can even get a PhD in fish biology, depending on what you want to do. So it's really just all about doing something you love. And one of the things I always tell people is the best part about being a fish biologist is you go out and you do all this physical work and you're pulling nets and you're counting fish and you're doing all this stuff and it's raining or it's really hot. And then when you think you can't take another day in the field, you're just exhausted, your muscles ache, then the field season's over and you get to go back in the office, summarize all your data, write some reports, maybe give some presentations to a classroom. And so it's this really nice balance of being out in nature, but also getting a little rest in there. So that's enough about me and the career path. We also want to talk about the Mokelumne River. So you guys have all been to the river, it sounds like. You've been to the hatchery. Have you been to the river closer to home? Because the river goes right through Lodi, right? Goes right through your back door. You can see right here, here's Lodi, and this red line is just a representation of the Mokelumne River. And the Mokelumne River starts all the way up in the mountains, really high elevation, and then it comes down, cuts down through the valley and into the delta, and goes all the way out to the ocean. I mean, this is pretty cool. Like, I think when I was young, I didn't really realize, like, oh, it's a river, it's great. Where does it go? Where does it start? So very cool. And then We talk a lot about the watershed. We protect the watershed. So like I said, the river goes all the way up into the mountains, right? So the mountains are high like this. So it's all that area that when the rain or the snow hits, it all funnels down to that one location and goes down the river. And that for the Mokelumne River is highlighted by this green area right here. So this is our watershed that we're dealing with. So all of this, there's a mountain rim right here. There's another mountain rim right here. And all that snow as it melts comes down and funnels right into the Mokelumne River and comes down right through the center. So that's what we're looking at. And then why does a company that sells water in the East Bay care about the Mokelumne River and what am I doing here, right? So this is the connection. This is our Pardee Reservoir, and this is Comanche Reservoir where the hatchery is down here. We actually, EBMUD takes water from the upper reservoir, sends it through an aqueduct system all the way down to the East Bay so that all the people in the East Bay have clean, clear, reliable water to drink. And so when we did that, we caused some impacts to this part of the river here because we put these dams, we stopped some natural processes from happening, we stopped gravel from moving down the river, we stopped salmon from being able to go up higher into the headwaters. And so we have a responsibility now to make sure that we're not causing any more impacts and that we're alleviating some of the impacts we've already caused. So that's what I'm doing here. And so our watershed, it's not a huge watershed. It drains 700 square miles. It may sound huge, but it's a pretty small watershed, but it does go up to a pretty high elevation. About a third of our watershed is above 6,000 feet, which means that's all snow. So it's really good when you have snow coming into the watershed because what happens is the snow all falls in the mountains and stays there. It stays there from November through March, April, and then things start to warm up and it kind of slowly starts to melt. And so the water operators love that because they see it coming, they know how much is up there in the snow, and it comes down in like a really slow trickle. And there are some watersheds that aren't that high of elevation, they're a little bit lower. The Cosumnes Basin is a good example, and that's a rain-fed watershed because most of its watershed is in lower elevations. So they get all their water as rain, and so it just comes when it comes. When it's raining, you guys know down here the streets might flood a little bit. So what we're tasked with monitoring is the river, the watershed, and our two reservoirs. And so I think these are just some pretty pictures of like us, the Mokelumne River up in the mountains at its headwaters, cutting down through the floor, getting to the valley. And then we get down to our two reservoirs, Pardee Reservoir and Comanche Reservoir, and then some of the land management we do. I just showed a picture of cattle grazing. You might think cattle grazing is just some private landowner grazing some cattle, but it really helps us keep all this grass down, which is fuel for wildfires. And we can manage that depending on where they're doing it in the watershed in different ways. So you guys learn what a reservoir is versus a lake? Yeah, the answer is right up there. Yeah.
It holds water?
It does hold water, and it's made by us, right? So normally this river just went kind of straight through from the mountains down to the valley floor. It carved itself all the way down. But people put these dams in so they can control how that water moves through the river system and for different reasons, right? So Pardee up here, we use that for the drinking water supply. And then downstream Comanche, we use that for flood control. So that way the city of Lodi doesn't flood in a really, really wet year. We can hold some of that water back right here. We also use this for irrigation for agriculture downstream. You guys know what like the big agriculture crop, some of the crops in Lodi are? But grapes. Yes, grapes. What else?
I think almonds.
Almonds, yeah.
I think there's some cherries.
There are some cherries, yep. Some of the places we go sample the river, there's some really beautiful cherry trees. It's hard to pass them by and not pick some cherries. And there's walnuts. So we provide water for some of those uses. And then there's other folks downstream that also have water rights. So we have to make sure like landowners along the river can take water out of the river. We got to make sure there's enough water for everybody. So this is our drinking water reservoir. Some of the cool facts about our drinking water reservoir, it is a small reservoir, doesn't hold that much water. This shows 203,000 acre feet, but it's shaped like this. So it doesn't hold a lot of water, but it gets really deep, and that really deep water gets really cold because it's collecting that snow melt, right, when it first comes in, right, it settles at the bottom. Cold water is denser than warm water. So it holds together tighter and it sinks to the bottom. So we really like that cold water at the bottom. But it doesn't hold that much water, right? And then we use that for drinking water supply because it's the higher quality water. But then as we move down to Comanche Reservoir, Comanche holds twice as much water, but it's big and wide and flat like this. So it doesn't get that cold. But the fish down here, the salmon, they need that cold water. So that's one of the tricks for us, managing those two reservoirs together, trying to make sure everybody gets what they need. So we have the fish hatchery. It sounds like you guys all went there. It's a great place. This is an aerial view of the hatchery. If you guys saw them spawning fish, you probably saw that right in here in this building. And we built that in 1964 because we built Comanche Dam in 1963. And the California Department of Fish and Wildlife said, you just blocked a bunch of habitat for salmon. So now you're responsible to grow a certain number of salmon in this facility that should have been able to go upstream and spawn naturally. So that's what we do in this facility. We raise Chinook salmon for mitigation and also steelhead trout. So steelhead trout looks just like a rainbow trout if any of you guys fish in freshwater for rainbow trout. Same thing, except a steelhead will go to the ocean and get a little bit bigger than like a normal trout you might see in a stream like this. The one that goes to the ocean for the Mokelumne might get this big. That's pretty big steelhead for the Mokelumne. But so we also grow those at the hatchery, and those are actually federally threatened under the Endangered Species Act. So there's very few steelhead. They have kind of a crazy way of living their life. They kind of do all sorts of things, so they're really hard to manage. Chinook do the same thing every year. They come back to the river in October. We spawn them. They leave the river by May or June. And they do the same thing over again every 3 years. Steelhead, they like to live by their own song, right? They go at year 1, at year 2, at year 3. They might go out on a winter storm when it's cold and drizzly outside. They might go when it's getting warmer. So as a biologist, I'm trying to count them, trying to monitor them, trying to see what they like, what they don't like, but they're all over the place. They do all kinds of crazy things. So it makes it really hard to manage, but we do our best. And then the salmon that come into the hatchery, we have two different things that these salmon can do. We talk a lot about the hatchery, and the hatchery is a really great place to see all the action and see what's happening as far as propagating the species. But they actually have this hatchery life cycle where the adults come in, we artificially spawn them, we take their eggs and rear them into young, and then we move them out to the river. But the fish in the wild are doing the same thing. Only some of the fish go in the hatchery. So you can always, if you go visit the hatchery, encourage your parent or your teacher to go down to the river too. You can always see fish spawning naturally in the river doing what they're meant to do. So they do both of those things. And this is a busy slide, but this is a busy time. So that's why it's a busy slide. Because when the salmon are coming up, which is right now, they're starting to come up. We've got a good number right now, haven't hit the peak yet. They come up into the river. Right here you can see we put this barrier fence below the dam because we don't want the fish to get down right below the dam. There's nowhere for them to spawn, and they might just die and never release their eggs and never contribute to the population. So we put that little barrier fence in. There's a little gate right there, and the fish will find their way into that gate. They climb up this ladder, which is really just a series of pools with a little weir in between. So they make a jump, they get to rest, they make another jump, they get to rest, make another jump until they're all the way into the hatchery here. And then we crowd them into the building. You guys have probably seen this part. It's a little dramatic, but the thing that I always tell people is they're gonna die after spawning anyway. Salmon always die after spawning. So they're called semmelparis. It just means they die after spawning. Steelhead, again, are iteroparis. They'll keep spawning and living, so they're just doing their own thing. So we line them up, females and males, and then we have people that actually just take the eggs out, take the milk from the males, pair them up, and we're on our way. And there's a ton of data we get from the hatchery. It's super helpful, not only for the hatchery production, but also for what we're doing in the river. So we know how many fish are coming up into the river because we have a video monitor at Woodbridge Dam down here. And so when we count the fish that go into the hatchery, that gives us a nice way to estimate the fish that are in the river. So we take that total count from Woodbridge, subtract out the hatchery, and that's what's left in the river to spawn. We can count their eggs. There's actually a cool machine in there. They throw all, once the eggs are hardened, they're easy to handle. They throw them in a little like spinning wheel machine, and it literally counts and spits them back into a tray. So you get an actual count of every egg that a salmon puts out. We can tell how well they're surviving. And then we put them in a truck, and we put them in places where we think they're gonna survive really well, because we wanna see them survive either to get caught in the ocean or to come back. and places where they are going to be able to find their way back to the Mokelumne. So salmon like to home to their home river, but sometimes there's inputs from other rivers that make it very confusing. So we really think long and hard about how we're going to release them so that they'll come back to us. And then, so that's all done by California Department of Fish and Wildlife in the hatchery, because we have this cooperative agreement. We built the hatchery, we pay for it, we pay their salaries, the California Department of Fish and Game runs it. And then East Bay Mud staff, we get to do the fun river stuff. So we get to do all the cool things in the river, video monitoring, carcass surveys, red surveys, screw trapping, which some of you may have seen down below the Lower Sacramento Road Bridge, a big metal trap that's kind of spinning like this. It looks like somebody dropped their cement mixer in the river. That's actually a fish trap that we're using to count the little tiny guys as they go out. And then seining, which is just pulling a net through the water to see where those little fish are using like habitat like this. They really like shallow shoreline habitat because there's lots of vegetation and bugs and things for them to eat. Electrofishing, so we use electricity to catch fish, to monitor them. It doesn't kill them. They're actually attracted to the current. So if we put a little current of electricity in the water, they'll swim towards it. And as they swim towards it, we can net them up before it injures them. And then acoustic tracking, kind of newer technology, very cool. We actually do surgery on fish, which is, I get to like pretend to be a doctor for a little bit, make a little incision in the fish, put a tag in there, stitch it up with like human type stitches. And then we can track them all the way out to the Golden Gate. So lots of cool stuff going on in the river. I think the next series of slides, I'll just kind of go through quickly. This is what our video monitoring looks like. You can see, we see adult male, very clearly adult male. You can tell the females have a little tiny head and a big fat belly. Otter. We've got lots of things in this is a native fish called a pike minnow, also using the ladder, but we get lots of really good data. This is a steelhead over here. And then the carcass surveys, so we actually can use even the dead fish. We get information as biologists from the dead fish. We'll collect a dead fish. If it's missing a fin, we know it's been marked in the hatchery, so we'll take its head back to dissect the tag out. We'll take genetic samples so we can tell which run it's from genetically. And then after we catch a dead fish, we cut it in half so we don't re-catch it because that might ruin our estimates of what we're doing out there. Red surveys, does anyone know what a red is?
It's like what they call the eggs.
Yep, that's their nest, is called a red. And so we go out there and count those. So we count like when they put them in the gravel, how many there are, and we can actually estimate when they're going to emerge, when the babies are going to come up out of the gravel because they're very dependent on that temperature. The warmer the temperature to a point, they'll mature faster and come out of the gravel faster. And here's that rotary screw trap I was talking about. It looks kind of like a cement mixer in the water. So fish actually get pulled in here because this creates a current that kind of sucks them in, and then there's a little live well on the back. So we can count juvenile fish that way. So we're really out there counting every stage of the life history in freshwater, so we can kind of see where are we losing fish, what do we think some of the mortality issues might be. Seining and electrofishing gives us good data on fish like this that could be predators to salmon, how many there are, how big they are. We can actually pump their stomachs and make them throw up, and then we can see what they're eating. And then this is the acoustic telemetry. Like I said, we do surgery, actually put a tag inside the fish and stitch it back up and let them go. And that's a really successful, fun way to find out where the fish are going. Habitat restoration. So the dams block all the normal gravel that would move through the system. And so we have to replenish that ourselves because the dams continues to block it. So every year we put gravel in the river, and we've designed it so that the river will move the gravel itself with its own flows, like a natural river would. And then we can kind of play with how the water is released. So we have requirements for how much water base flow we flow down the river at all times of the year. But sometimes we can kind of pull up some of that water and shape it in a way. So what this graph is showing, we pulsed a peak of water, and then we see a peak of fish. A peak of water, a peak of fish, a peak of water, a peak of fish. So we've changed the way we manage flow in the lower river from years and years of data collection and figuring out that, hey, if we do this, we can actually increase the number of fish coming back. And we've been doing it since 2009, and it's a super, super successful program. Using the same amount of water, so it's not wasteful, but releasing it in a way that the fish like it better. And then the other thing that's super important for salmon is they need cold water. And it's really limiting where we are. You know how hot it gets in Lodi in May and June. So all of that air heats up the reservoir, right? And this is Comanche. So it gets really hot, and there's not a whole lot of cold water in Comanche. So what we've learned to do over time is taking this larger volume of cold water from Part E, and instead of, our operators used to just kind of trickle flow from Part E into Comanche over the summer, all through the summer, just kind of, just a regular stream of flow. And what we realized was if we hold that water back and then we shove it down in these big giant pulses, that water will stay together. Like I said, it's dense and it'll sink to the bottom. And instead of going into the reservoir and kind of dissipating across the top, if there's not that much, it'll actually go and dive right down to the bottom to the hypolimnion where we want it. And this is where the water comes out of the dam to the river, right at the bottom. So we can push all that cold water down. We start doing that in September, so that way when the fish come up in October, we can release it down and time it right so the salmon get the coldest water possible for spawning. And you know, why does all this matter? You know, part of what I'm trying to do here today is instill the value of, you know, nature, enjoying nature. These are public trust species. They should be around for everybody. We shouldn't be able to just build dams and then walk away. And so it matters. This is a historical mitigation for us, for sure. But everybody on my crew has been around probably 10 plus years. We're all very attached to this river. We care a lot about this river, and we do it because we love it and we like to see these improvements. You know, there's ecological importance. Rivers have to be able to move their nutrients around and create food and move gravel. And if we have a healthy river, we can expect a healthy salmon population and vice versa. And you know, we're looking for environmental indicators. These fish, salmon, are sensitive to water temperature. They're sensitive to pollution, different flow regimes. And so, you know, we see these shifts in the salmon population, and we can tie those to anthropogenic factors. That just means factors caused by man. Like the things that we're doing affect these species. And so it's our job to kind of mitigate those effects. And then of course, there's selfish reasons to do it. You saw that picture of me catching a great big giant salmon in the ocean. I want to catch salmon in the ocean, right? So there's a commercial and recreational benefit. These fish are very important to local tribes in the area. We provide salmon for local tribes from the hatchery for them to use for ceremonial purposes, for traditional food source. Yeah, and so there's lots of really good reasons why we do what we do. And here's the culmination. Look at all this success. These bars are the number of salmon that we're seeing come back to the river. And you can see when we first put in the dams, the returns were kind of low, but they're steadily going up. And that's really rewarding to see as a fish biologist. And last slide. We are inviting you guys to be part of our success, right? So we want you guys to feel some of the success. This is your watershed, right? And you can start at home. Conserving water, recycling, reducing waste, being mindful about what goes in the storm drains around your home. You know, when you go out to a natural area, make sure you pick up your trash, keeping those areas beautiful and clean for the species that use them. Respecting the environment and wildlife by following laws and regulations. They're there for a reason. You know, the laws aren't there just to limit what you can have. They're based on all of this data that we collect on the status of the population. And, you know, we have invasive species. We're so close to the Delta. What happens in the Delta? There's lots of ships that come into the Delta transporting goods and services from other areas. You have to really be mindful for invasive species. So you can help though at your level. If you guys have a little fishing boat or a kayak, you know, if you clean, drain, and dry that before you take it to a new water source, then you're being part of the solution, right? And we are always here. We're right in your backyard. We're always interested in answering any questions you guys might have and being available for you guys if you're interested. So that is what I have for you today.
Is one of the invasive species the golden mussel?
Yes, that is a very high concern invasive species in the Delta right now. We don't have it in the Mokelumne River at this point, and we're being very, very cautious about how we manage access to our reservoirs and the river to try to keep it from infesting our waterways. But in the Delta, it is definitely established, and it's gaining traction rapidly, and it will be a big concern, not only for, a lot of the big concerns are if you have a pipe this big and you get a bunch of golden mussels in, then your pipe becomes this big, right? And you can't deliver water. But the other thing that mussels do is they're filter feeders. So they're just out in the river, out in the reservoir, and they're just doing this, sucking in water, eating all the good stuff in it, and spitting out clean water. And what that does to the food chain is it stops the primary production. Like the very first part of the food chain gets obliterated, and then there's no food production for fish. So we have ecological concerns and also infrastructure concerns with golden mussel.
All right, up here in the front, did you?
Is being a fish biologist necessarily hard or difficult?
No, I don't think it's hard. It's super fun and super rewarding. You have to like the sciences, because the degree you have to get to be a biologist, you have to take a little bit of chemistry, not a whole lot, and lots of biology classes. But I will tell you, I originally started off as a pre-med major, and the classes I was taking were like immunology and bacteriology and serology. And so I was in a lab looking through a microscope, and then I took one of the field courses. So awesome. The field courses, like I took mammalogy. We went to the Sutter Buttes and we trapped ringtail cats. And you know, all these field trips where you're like out there doing things like, oh, this is way better than looking through a microscope. So you got to think about what you like to do and then find a way to incorporate that into what you do. My degree wasn't terribly difficult. You know, I'm not an engineer, I'm not like a brain surgeon. Fish biology is totally manageable for everybody.
Because you said that you used to catch lots of like salmon and all that. What's the biggest salmon you've ever caught?
Well, I will say that one in the picture that I showed, that was my prize salmon. I think that was maybe 26 pounds. But in the hatchery, our record salmon was like 45 pounds. So imagine, I'm going to guess some of you are probably 45 pounds. But it was like a big, I'm going to say it was like this big, but like this deep. It was such a big bodied fish. Very, very cool. So, and those are, so our hatchery population is mostly 2-year-old and 3-year-old fish. Sometimes we get some 4-year-olds. That giant fish was probably 5 or 6 years old. And up in the Pacific Northwest, like in Alaska and Washington, that size of fish is a little more common. They grow to a little bit larger size.
So on one of your slides, like it was with like different animals, or like the fish and the otters were in the.
Oh yeah, in the video.
I forgot what it's called. But are there able to be like more than one of those in each?
Yes. So we showed you the PG version of the otter in the ladder because the PG-13 version, those otters are in the ladder because they're chasing fish. So it makes me really mad at otters, but they're just trying to do what they normally do, right? But they get in the ladder because there's fish in there. And so we see them all the time in the ladder chasing fish around. And when the run is really at its peak, that camera screen will be filled with adult fish. And my staff has to sort through and try to watch them because they mill around a little bit and go back and forth and kind of fight with each other. And they kind of have to watch every time one goes up and count it. You know, one goes up and count it. So those ladders can get really crowded.
Are there any predators for the fish eggs in the Mokelumne River?
Yes, for fish eggs and for young fish. I'll start big. So like a big salmon, if it was able to go a little higher in elevation, might get predated on by a bear or like an eagle or something like that. Our baby fish, we have predatory fish that grew up in this river that belong here, like that pike minnow I showed. That's a native fish that predates on salmon, but they've kind of evolved together, and so they kind of do this. Their populations stay normal. Our biggest concern in the Mokelumne River is striped bass. So that's not a native fish. That's a fish that was brought over from the East Coast because it's super fun to fish for. They're super active fighters. Yeah, great to fish for. So they brought them over here for a fishing resource, but they love to eat baby salmon. and they do a really good job of it, unfortunately. So some of the things that we do, we'll use that electrofishing method, and we'll shock up a bunch of striped bass, and we'll move them downstream to an area where they don't have such access to the salmon. So it gives the salmon a little bit of a fighting chance to get out of the river. And then the eggs, we even have little tiny benthic fish called sculpin. If you guys fish, your parents might call them mudsuckers. A little tiny fish on the bottom. Sometimes they hang out right behind the fish while they're putting their eggs in the river, and they'll just, because some of the eggs don't get buried, they kind of float away, and they'll just sit there and pick off eggs while they're there. So every life stage gets eaten by something. That's just part of the life cycle.
All right, last question here.
What would happen if all the reservoirs and lakes and the river would have mussels in it?
I shudder to think about it. It would be very devastating for lots of reasons. Like I said, it's going to clean out that water. And so if you like to fish for largemouth bass, those might be compromised because they can't get any food, or they're eating those mussels and they can't digest them, so they die of starvation with a belly full of mussels. Things like the hatchery has a ton of different pipes of water, bringing water into the egg stacks and the troughs and the raceways. If all of those get clogged, then we could have a catastrophic fish kill at the hatchery because there's not enough water trickling through. Same thing for water supply, the water going down the aqueducts. The aqueducts are probably fine because the aqueducts are giant, I don't know how big they are, but they're big. Mussels probably aren't going to attach to that and close up the aqueducts, but once they get down into our distribution area where people are trying to use the water, you get smaller and smaller and smaller diameter pipes, just like as you get to your house, there's a water pipe from the street, and it's probably this big. It's probably a 3-inch pipe, maybe probably this big. It's probably a 3-inch pipe. So imagine, it's not going to take very many mussels to clog that up and stop the water from coming into your house. So lots of concerns.
All right, thank you again. Can we give her another round of applause?